STEM NOLA is my favorite place
Why is STEM NOLA your favorite place?
because I get to do activities.
Hey, good afternoon. I'm Dr. Calvin Mackey of STEM NOLA, and welcome to our live session, STEM NOLA at Home. This is our third session, and it's buoyancy and density. Can you layer liquid? And we're so excited because parents, we've been getting your feedback, and our goal is continuous improvement, and that's what we've been doing. Just to tell you a little bit about STEM NOLA is a nonprofit founded in 2014 to expose and inspire and engage communities in science, technology, engineering, and mathematics. In the last 6.5 years, STEM NOLA has engaged over 40,000 kids and over 10,000 families. We hire college students as interns, as our staff. We put over $700,000, in the hands of college students over the last 6.5 years, and we're very proud of that. We're ready to engage you all today in density. And again, we believe that STEM should be culturally and environmentally relevant. Why are we studying density? Because it is relevant to what we're talking about in terms of COVID. Remember, in COVID is an airborne disease, and they say, socially distance and stay 6 feet apart. It's because when you cough, or even when you speak, like I'm speaking and projecting, the virus can actually be in the particles that are coming out of my mouth. And as those particles come out of my mouth, they've done experiments to show that if you're 6 feet apart, just regular speaking, then those particles, due to their weight, will fall to the ground. Well, what they also have been studying is that these particles are of different size, but also as these particles are traveling through the space, they actually can evaporate. And when they begin to evaporate, it becomes smaller. So you have big particles, smaller particles, and the particles of different sizes. So the lower the density, or the bigger the density, determines how fast the particle pulls to the ground. And last week we studied drag. So what is pulling the particle to the ground? The gravitational force. The drag on the particle from gravity brings it to the ground. And that's why we're going to go back to the fact that we must wear our mask. The mask works because the drag due to the particle, when the particle trying to go through the mask, it is blocked. And also the particle that may get you the mask has been damaged or reduced in size such that it may fall out faster. It may not reach another person. So the mask works. And that's why we're so happy today to go through these activities on density. And we hope that you all get it. And parents, educators, we believe that if we can explain to our kids, physical phenomena in such a way that they can digest it, so when they get in your class, it becomes something that they really can apply and work with you with when you're trying to teach them in a more in-depth way. I'm also excited today to do this activity with our partner Chevron. Today we're going to have a professional from Chevron, Shirley Luce Inambo, explaining how density works in the whole petroleum industry and also in what she does with Chevron. Thank you all. We're going to have a college student, Holly, working with you all. So I'm just excited that we are once again engaging you all in your house. And we're going to continue to do this as long as we can. Thank you, Calvin Mackey. I'm out.
Hello. As Dr. Mackey said, my name is Shirley Ruth Anambo. I work as a process engineer at Chevron. I graduated about 4 years ago from the University of Oklahoma with a bachelor's in chemical engineering, and I now work as a process engineer. I'm really excited to talk to you guys about density today. It's because it's something that applies to my work every single day. So what I do as a process engineer is work to separate the reservoir fluids as they come up from the oil well. So you have oil, water, and natural gas all mixed together. And my job is to separate it and send the 3 parts to their separate ways. So we clean up the water and send it overboard. We dry out the oil and remove all the water from it and send it down the pipeline. And we do the same with the gas. So as you guys probably know, oil floats on water because of the difference in density, and we can use that to our advantage in separating the oil and the water. So unlike in a lot of other chemical processes where you have to add additional chemicals or a lot of energy in the form of heat, we can actually separate oil and water pretty easily due to their natural properties. So what we do is basically take the reservoir fluids as they come up and send them to a giant tank. We call it a separator. And the separator has basically a wall in it called a weir that separates it into two compartments. So as the oil and water enter the separator all mixed together, because of the density, the oil particles will float to the top, the water particles will fall to the bottom, and you end up with two layers of oil and water. The oil ends up floating over the weir into a separate compartment, like you can see on the screen, and the water stays behind. So we can take out the water from its compartment and the oil from the other compartment and send them to their separate treatments. So it's actually very cool that we're able to use something that's natural in oil and water and doing something that makes the oil something that we can actually sell and the water something that's safe to put back into the Gulf of Mexico. So it's relevant and it's actually tied into the experiment that you guys are doing today because you'll be adding oil and water and seeing the difference in density. Hope that helped you guys understand a little bit more about how density works in the real world.
Hi, and I'm Holly Griffin. So I'm going to be getting started with y'all. I'm a college student at the University of New Orleans, and this is our agenda for today. We got a lot we're going to get to, and I'm pretty excited about it. So we're going to go over what we're going to be doing, our vocabulary terms, Archimedes' principle, and also our goals and objectives for the day. We're going to address our questions before we do our experiments so you can get that in the forefront of your mind. And then we're going to do our two experiments, our sugar density column and our layer density column. Then we'll come back to those questions, we'll address the answers, and then we're going to have Mr. Mackey come back on, and he's going to give you and address your answers and questions. So, all right, let's get started. First order of business is what we're going to do is prep our sugar density column experiment. All right, so get all of your supplies ready for that real quick. You want to get your cups out. All right, and that's going to be 5 cups. That's going to be your food coloring. And that is going to be your warm water. So with the warm water, we really want it to be warm water. We don't want it to be boiling hot and we don't want it to be cold. So go ahead and get your water prepped right now. It's going to be about 2.5 cups of water. So the best way to do that is just go ahead and put it in the microwave, maybe warm it up for like 30 seconds, 45 seconds at the most. We really don't want it boiling hot. And then you want your sugar. You want your plastic cups, again, which is 5. And if you don't have plastic cups, don't worry about that. You can use your household cups. And we are going to put food coloring in them, so parents don't worry. Just use some alcohol, rubbing alcohol, or Dawn soap to clean those cups up, and that food coloring is going to come right off. All right, and the science behind that way, I'll getting everything prepped, is we're going to be addressing density in this one. And density is how much stuff is packed into a measured space. And so that means how many molecules is inside of something. So we have something like, let's say, a foam block in a brick. This one's going to be less dense and this one's going to be more dense. The reason why is because this has less molecules in it. It's got less weight, it's got less mass, and this brick is more dense. It's got more molecules just jam-packed, tightly fixed together. So that's what we're going to be measuring with this. We're going to have water and sugar, and we're going to have a cup of water that has no sugar in it, and then we're going to have also a cup that's got a lot of sugar in it, and so that's going to have more density. So that's what we're going to be doing today. So we're going to get that prepped. So again, we need our food coloring. We need our sugar, and we need our warm water. All right, so hopefully y'all got that warm water. If not, don't worry about it. I'm gonna get my stuff preparated while y'all are still working on that. Get my food coloring. And the first order of business is we are gonna pour our water in. So no matter how big your cup is, we really just want about 4 fluid ounces or like a half a cup in there, okay? All right, so pour it in. And make sure you've got an even amount. It's okay if it's not exact. Don't worry about that. And be very careful while you're pouring because it is warm water. I do not want y'all to burn yourselves. Parents, if y'all want to pour the water, might be best. Depends. Whatever you feel more comfortable with. And then the next order of business, when you've got your set amount of water, we're going to add our food coloring. All right. And I'm going to go ahead and give you a chance. Pour your water. I got to slow myself down when I get started on something. I like to go, but so I'm sorry about that, but we'll do it. All right. So, and notice you probably, if you got food coloring, you probably have 4 colors and we have 5 cups. That's okay. We're gonna make our own color with this one by mixing two colors together. We're gonna have red, yellow, orange kind of, green, blue, and purple. And purple is our two primary colors, blue and red. We're gonna mix that together. So I'm gonna go ahead and get started. And you might wanna pour 2 to 3, best for your colors. If you wanna pour more, wanna pour less, that is absolutely fine, it's up to you. But about 3 drops is a really good color just to see the difference, the spectrum of the rainbow is kind of what we want. All right, so I got my red, I got my yellow, do my blue and my 8. And I'm gonna do my green and my 4 tablespoons. All right, and this is where we are gonna make our purple. So I'm gonna do about 2 drops of red and I'm gonna do 1 drop of blue. And I accidentally put green, so I'm gonna have a very interesting purple, but that's okay. All right, and so with the measurements, I've got my cups labeled. Don't worry if your cups aren't labeled, but I've got mine labeled. So my red is gonna be the first one, which is gonna be my least dense. That's gonna have no sugar in it. Then I've got 1 tablespoon of sugar in my yellow. So we're gonna do just 1 tablespoon in that one. Then for green, I've got 4 tablespoons of sugar. And then for blue, I'm gonna put 8. And for my interesting purple, I'm gonna put about 12 tablespoons of sugar. All right. Let y'all get y'all's color situated. I'm gonna get my sugar out. You might need a lot of sugar. I got a big old cup of sugar right here, about 12 ounces of it, so 12 fluid ounces worth. All right, get my measuring spoon. And if you don't have a measuring spoon, that's fine too. If you've got like a regular household spoon, you might wanna use like 2 scoops for a tablespoon. You really want like a bigger spoon, one of your biggest spoons that you got. But if you've got a measuring spoon, that's the best case scenario. So what we're gonna do is add our sugar. Remember for your red, that is 0 tablespoons of sugar. We don't want any sugar in that. All right, and then for yellow, and this is also why I've got 5 different spoons. And again, if you don't have 5 different spoons, don't worry about that. If you've got 1 spoon, just have a napkin with you so you can just go ahead and clean it off. All right, so I'll just put my spoons in and prep myself real quick. And then I'm gonna add my 4 tablespoons. I'm probably gonna come back and mix all my sugar after, just because I wanna get all my sugar in the water. I'll give it a little stir, but not too much, because it's gonna take some little elbow grease to be able to get it stirred the way I really want it to. I gotta mix that sugar in well. So for my blue, that's the one with 8 tablespoons. So we're gonna be scooping quite a bit. All right. I'll go a little slower just in case some of y'all are trying to catch up. I know I can be speedy, so you have to work. All right. Got about 8 in there. And you're gonna see it's gonna build up. It's gonna be a lot of sugar that you're gonna have to stir. And that's why we got warm water, because it's gonna be easier for it to dissolve. If we put it in cold water, it really wouldn't dissolve that well, because those molecules would just kind of stay as solid. We want it to dissolve into the liquid pretty well. Alrighty. So purple, that's the one that we're gonna have a lot of scoops in. Put 12 in that one, because that's gonna be our most dense. And it's our last color of the rainbow. So that's 6, 7, 8, 9, 10, 11, and 12. Okay. All right, so now I'm gonna start stirring. I'll probably start with 12 because I'm gonna need to stir a lot, and I really wanna make sure that one's mixed up really, really well. And if you've got maybe your brother, your sister with you, or your mom or dad or somebody helping you out, get them maybe to help you stir the sugar too, so y'all can get it done faster. Just because it's a lot of sugar you have to stir. And when you're stirring it, if you still hear kind of like this crunch noise when you're doing it, you're gonna have to keep stirring. You don't wanna see the sugar and you don't wanna hear it anymore. You'll know when it's dissolved when you don't hear it. Mine's kind of starting to go away. All right. So we're gonna make sure we stir it really, 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 really well. And I'm excited for the end result for this one because I really like the way it looks, because we get to see a rainbow. Because we're gonna pour it in a cylinder container, and then we should be able to see the rainbow spectrum of all the liquids stacked up on top of each other. And that's our goal. So I think that my sugar is pretty much mixed up. How y'all doing? I wish I could see you face to face so I could actually hear you, but I hope y'all are doing all right. I'm sure y'all are doing good. My sugar looks like it's pretty mixed in well together. All right. So what we're going to do now for this, because we have two parts for this one, this is our preparation work. We're going to take these cups, and I highly, highly recommend that y'all put them in your fridge, or maybe even your freezer would be the best case, because what we want to do is cool down the temperature so we can get the best result when we put it in our cylinder, okay? We want to be able to see that rainbow spectrum and really get them to stack on top of each other so we can see the effect of different densities in the liquid. So go ahead, I'm gonna give y'all some time right now to take your cups, try to make some space in your fridge. I know you'll probably bought a bunch of meat and stocked up on eggs, but try to make some space in your fridge or your freezer and put your cups in there, okay? That's what I'm gonna do right now. Hands it over. Alrighty. And then we are gonna move on to our vocabulary terms. So we're really gonna get started with the beginning of our agenda. All right, and I may have used the term density. Maybe some of you don't know what density is, and maybe some of you do. And in the cup with no sugar, remember when you put that in, it's just water. It's just food coloring, and it's just water. We don't want anything else inside of that. We just want basically a pure substance. It's going to be less dense, because that's our less dense one. And then that purple one's got 12 tablespoons of sugar, and that's going to be the most dense. So let's get started with that vocabulary. These are things we want to keep in the forefront of our mind, address the science of it, address why we're here and what we're learning. So we've got 4 big terms that we really want to keep in the forefront of our minds. That's density, that's mass, buoyancy, and displacement. So with density, again, I talked to you about this brick, and I talked to you about this foam block. And you can see in that picture right there, you've got, let's say that that's the foam block with the less molecules, and then the brick is the one with the most molecules in it. This one's less dense, it's got less mass, and it's got less weight to it. So, and also when I put it in the water, since it's less dense, it's probably going to float. And if I put something that's got a lot more density, it might sink. It's got more mass to it. And speaking of mass, that is the amount of matter in an object, which is about how much space something takes up. So what do you think about it? You think this is less dense, think more dense, or you think, what you thinking so far about density? Because if you think about it, you know, something with less mass, it would be less dense. So we have a poll up for you. What do you think is going to be less dense? You think a feather would be less dense? You think a brick would be more dense? Or you think they'd be the same? It looks like y'all are turning them in pretty quick. Most of y'all are getting it pretty right. I'm confident in y'all. And I'm pretty impressed with y'all's answers. Okay. Alrighty. Y'all are pretty quick with the answers too. I'm impressed. Alrighty. So it looks like we got a pretty good grand total, and it looks 91% of y'all got the answer correct. I'm proud of y'all. And the ones that didn't, that's okay. That's what we're here for. We're doing experiments so we can learn about these terms. Okay? So we're going to move on to buoyancy. That's another topic. I don't think I really addressed that one yet, and that's density and buoyancy. Buoyancy is that upward force that's going to come. So when I put something in liquid like water, it's going to be the upward force coming down. So I've got gravity, which is this downward force, and I've got an upward force of buoyancy working on an object, help either keeping it afloat or maybe making it sink because of its density. So again, if I put this foam block in there, what do you think is going to happen? You think it's going to float? You think it's going to sink? You float. It did not really do much of anything. It didn't sink. It's because it's less dense. All right, and if I put this brick in here, what do you think is going to happen? Think it's going to float? I don't know. Let's try. Nah, it sank. So, all right. And so what we're doing also is talking about displacement. That's our 4th one. So I'll give it to you again real quick. And with displacement is when I put something in the water, I've got buoyancy, I've got gravity working on it, and displacement is actually that water that's coming up from the side. So when I put this on the water, you see the water kind of pushed to the side a little bit. And so it increases with the volume. It depends on how much volume I add to this water in this container. And it's going to cause the water to rise a little bit, but not too much. Nothing really happened when I put the foam block in. But when I put this brick in, you see the water level rise. And that's displacement taking its effect because the water can't go anywhere, so it's going to go up. It looks like there's more water, but there's actually not. And so those are our vocabulary terms. And if you're still having trouble, look at that picture. It's got a really good description, kind of an image of everything that we're really going over today. We've got fluid displacement. We've got buoyancy that we're talking about, mass and density. That's our really big picture why we're here today. All right, and so those are our vocabulary terms. Now we're going to quickly talk about Archimedes' principle. So that's kind of similar to what we just addressed with displacement. It's when I put something in that's got maybe some weight to it. It's going to make the water go up, right? So Archimedes' principle is about whatever this weighs, I should have an equal amount of water rise up in my cylinder. So I've got some water. We dyed it red so we can give y'all a good visual of it. And I've got some bolts here, and I've got, well, different size bolts. So I've got to try to get a lot of weight and add a little more volume to what I'm doing so we can really make that water rise. So what do you think is going to happen? You think it's going to rise way up here, in the middle, not that much? I think this might be heavier than foam, so let's see. All right, so it's a pretty simple concept. It may sound like something big. All right, I almost got my object stuck in there. But Archimedes' principle is pretty easy. It's just about that fluid displacement. It's when I put objects in the water, depending on its volume and sometimes even its weight, it's going to make that water shoot up, and it's going to look like there's more water in an object, but really not. So that's what we're talking about today. It's really not that hard. It may sound like complicated terms, but we're making it easy, and we're doing some fun experiments for it too. So what we're going to do is move on to our second experiment. And before we do that, actually, I almost forgot we have questions and objectives to address. I'm ready to just roll. So our objectives, and the reason why we're here again, is that we, me and you, and all of our parents, everybody that's here with us, we're going to be able to understand the concepts of buoyancy, density, displacement, mass, and apply those things to our experiment. And then we're also going to be able to perform our experiments of creating a sugar density column and also our liquid layer density column. So quick, if you're listening, what experiment are we doing today? Let's see if y'all paying attention. All right. And I'm impressed. Y'all got it. All right, all right. And y'all did a pretty good job. Y'all did better than the last poll. I'm glad y'all keeping up with me. All right. So let's get started with this one. This one I'm really excited about because we've got a lot of different materials. So the questions that we're also going to be addressing for our two experiments, they're going to apply to both of those, is we're going to be just talking about the amount of density. So that bottom layer and that top layer, we're going to see, what does that mean? Why is it at the bottom? Why is it at the top? So our first question is, why is the bottom layer at the bottom? You think it's because it's more dense? You think it's less dense, or it's got more weight to it? What's going on with that? And why is the top layer at the top? When we pour these things into the container, why is that staying afloat? What about that liquid? What about that substance makes it be able to float? And then which layer is the most dense? Is it our middle layer? Is it our top layer? Is it our bottom layer? I don't know. I think I do, but we want to see if you know. So we're going to come back to that at the end, and I'm confident they are going to be able to get the answers to those questions. So now let's really get started. Our layer density column. So we've got a lot more materials with this one than the other one, but I'm excited about it. And it's okay. I want to quickly address, I know it was in the cards for the ingredients and stuff, but do not stress out if you do not have all of these things. If you've only got water, dish soap, milk, and honey, that is fine. You really only need 3 or 4 of these materials to try to get an accurate account of the different densities. I've got all mine here on the table so I can show y'all, but like I don't have lamp oil at my house, so I don't know if you have it at yours. Don't worry about it, it's okay. And if you have maple syrup, but it's not 100%, if you want to go ahead and use it, it still should work, but don't worry if it's not exactly 100%. And while you're getting all that stuff ready, we're going to address the science behind this one too. So liquids, they have different densities, and what makes something heavy is basically like its purity. So we know water, it's pure, it's only ingredient, and when it's pure, we mean that it only has one ingredient, and water, it's just water. But let's say we have something like vegetable oil, that's not a pure substance. It's got all kind of stuff inside of it that makes it to be vegetable oil, and it can make it heavier, it can make it lighter. We're not sure, are we? That's what we're here for, is to measure the different densities. So that's what we're going to be doing, is looking at all these different liquids, and we're going to see which one's at the bottom and which one's at the top. And it's really cool. It looks really interesting. It can get kind of messy, so just make sure that you're in an area that you're okay with maybe getting a little messy. Maybe have some napkins, because we've got stuff like honey and corn syrup and maple syrup, and that can get a little sticky. So just make sure you got some Germ-X and you're in a space that you can get dirty. So let's get started, and I'm going to get y'all some time to get all your materials together. I've got mine in these little beakers, and I've got them at kind of the same amount. And also, if you don't have something like this glass cylinder right here, that's fine. Don't worry about that. You can use even like a plastic water bottle, and that'll work just fine. And when you pour your amounts in, try to keep it at, let's say, like an inch. for each level, because we don't want to pour too much because it's going to overflow, and then you're going to have a very big, sticky, stinky mess, and you don't want that. So let's get started with our experiment. Also on it, we saw that we had some flashcards, right? So we had some flashcards that we prepped and put the name of each material that we're going to be testing. So if you didn't prep yours already, I'm going to give you time to do that too right now. Get either a piece of paper, maybe some index cards, and go ahead and write the name of each ingredient you have, like your lamp oil, your alcohol, or if you only got 4, you just need 4 little pieces of paper. Let's say maple syrup, let's say corn syrup, whatever you've got. And we're going to put them in the order of what we think is the least dense to the most dense, okay? So while y'all are getting that ready, I'll share with you my order of what I think is going to be the least dense and the most dense. And I had to think about it because we've got some stuff that seems like it'd be pretty heavy, but which one would be the most heaviest? Which one's going to be the lightest? Let's see. So I've got my first one. I think that lamp oil is going to be the one that's least dense. That's what I'm starting with, is what's least dense. So I got my lamp oil, and then I thought rubbing alcohol. It's really not that dense. It's a light liquid. It moves around a lot. It's got a lot of movement. It's not like honey where it's like a solid almost. It sticks together. Then I've got, let's see, I think vegetable oil is going to be next. So I'm going to put that one next because that's also got, you know, really movable substance, really movable liquid to it. So I think that one's going to be pretty light. And then we talked about water being really light. It's pure. So I think that oil, you know, it floats on top of water, and water is going to be maybe a little more dense than oil. So I'll do water next. Then I've got dish soap. I think that one's going to be a little more heavier than water. It's going to be a little more dense. And milk. Milk can get chunky. Milk's a little, you know, it's going to be more dense. So we'll get that together. And some of you may already be done if you already have 4. So it's okay, just get all your materials prepped. Make sure you have everything. If you need to grab something from the pantry last minute, go ahead and do that right now. And then I've got milk. I think that the maple syrup, my pure maple syrup is pretty thick. And then I'm going to do corn syrup because all these seem to be really thick, really dense. So I'm going to make that last. And honey, that one just sticks together. It's almost like molasses. It barely moves. So I'm going to put that one as last. All right. And if you want to, if it makes it easier for you, maybe put your ingredients by your card so you can know the order that you want to pour it in. So I've got my rubbing alcohol, my lamp oil, vegetable oil. I've got my water. I dyed it red so I can get kind of a different spectrum. And if you still got that food coloring by you and you have your water, go ahead and maybe put like a blue in it or put yellow in it or something so you can see a different color. All right, and then also, I think I'm going to do that with alcohol too. So if you've got rubbing alcohol at your house, maybe add some food coloring to that, different from your water, so you can see the different variations, and it'll look much cooler. I like the way it looks. So give it a stir real quick. All right, and then I've got my dish soap, which is pretty green. Yours might be a different color. I've got some milk. I have got my maple syrup. I've got corn syrup, and I've got my honey. All right, so in order to do this, which one do y'all think we should pour first? You think we should pour our least dense or our most dense? I'm going to pour my most dense because my layer at the bottom is going to be the most dense. It's going to stay at the bottom. So I want to work my way up. So whatever I think is going to float and be less dense, I'm going to put it at the top. So I'll start with my honey. And again, try to put like only about 1 inch of height. I'll move these out the way so I'll give y'all a better visual. All right. Let's see. So I'm going to pour my honey. Very, very sticky. Remember, please be in an area that y'all are fine getting a little dirty, and be careful when you pour it. So I think for my next pour, I'm probably going to hold it at this angle. Whenever you're pouring your stuff, probably hold it at about a 45-degree angle because it'll give you a better way to pour your things, and they'll probably stay on top of each other a bit better. We don't want to pour directly on top of our substances. So my next one, I put corn syrup. I don't know, guys. This one's a little thick too, so. And even if you want pour slow, try to get the most accurate pour that you can so it'll stay on top and it won't mix together. And if y'all have y'all's in a different order, that's perfectly fine because that's what we're here for, is to trial and test, make errors, make mistakes, or maybe you get it 100% correct. Who knows? That's what we're here for, is to do experiments and to test and see. And if you don't put it in the correct order, if you give it actually about an hour or an hour and a half even later and you set it aside, then you're gonna see everything balance out and you're gonna see everything kind of fluctuate. So next I'm gonna pour my maple syrup. And it looks pretty good so far. It doesn't look like it's mixing in. So I think I might be on track. I'd like to say so. I'd like to believe that. And I'm pouring a little more than an inch just to give y'all a better visual. But depending on the size of your container, pour how much you think would be best. If you're working with a plastic water bottle, don't pour about more than an inch because we really don't want it to overflow. All right, and then my next one, I think I have milk. So let's see what happens when I add the milk. Let's see if it shoots down or not. All right, I think it's working pretty good. It's not really sinking. It looks like it's mostly staying afloat, not mixing with anything else. It's almost a little gross. And I definitely don't recommend drinking it. Please don't. I know some of these you can eat and you can drink. Please don't. It's a science experiment. We don't want to eat with our science experiment. We don't want to mix that. In my next ingredient, I have dish soap. So let's see what happens with this dish soap. Try to pour it slow, and I'm on track. It looks like it's staying afloat. All right. How's y'all's going so far? Is anything mixing together? Or... Again, I'd love to see y'all face to face. I miss y'all seeing you at STEM events. All right. So it looks actually really cool and a little gross, but it's okay. And my next one, I've got water. So this one, let's see. Is it going to stay afloat? What do y'all think? I think it will. I believe it will. I believe I chose the right order. All right. This looks like it mixed a little bit, but mostly staying afloat. I don't see it pouring into my milk. Ooh. It's very interesting. All right. So be careful when you put it back too. So as it mixes, if it mixes together too, that's fine. Like I said, if you leave it back, if you leave it like on a table, just set it aside somewhere for about an hour, hour and a half, you'll see everything start to go on the level that it's supposed to go on. All right, and now I'm gonna pour my vegetable oil. Pour it really slow, and some of y'all might be done, so you can just go ahead and watch while I mix my spectrum. It just depends on how many ingredients you had. But if you are done, why don't you go ahead and leave in the chat if it worked or not, or see what's going on. I'd love to know. And also, I would like to see if y'all know what helps it not mix. What helps it not mix is actually me putting it at this angle. When I put it at a 45-degree angle and I pour it slow and it's kind of pouring onto the side, it gives it a better chance. If I pour it directly onto that substance, there's going to be so much force that gravity's going to be pushing that liquid down. It's going to mix all together. So that's why we're pouring it slow and we're pouring it at an angle. It's going to give you the best results, okay? So I've got, let's see, I got 7 out of 9 ingredients. So I'm going to add my alcohol now. I dyed mine green, so it looks a little weird. All right. And again, ooh, it mixed a little bit. I need to go slower. I need to follow my own advice, huh? Jeez. All right. And I'm going to hold that because I'm getting close to the top. But it looks like it's doing pretty well so far. Some of them kind of mixed just because I'm going back and forth with pouring it in. But overall, I'm getting a pretty good spectrum. Can y'all see that well? Yeah, it looks pretty gross. And my dish soap looks like it's mixing in. But again, if I let it stay, it's going to settle nicely. And another way, if you want to put in the chat and let us know too if it's working. But another thing we would love is if you could go ahead and send us a picture to STEM NOLA. It's at webinars@stemnola.com. And you could send us a picture and let us know what order you put your stuff in, because we would love to see your spectrum. Mine looks really gross, and I'd love to see the colors y'all chose and what you thought. Because originally when I first did this, I was having troubles like maybe honey's heavier, maybe maple syrup's heavier. I don't know. But that's why we're doing an experiment, is to see. So I've got all my ingredients poured, and I've got a pretty cool spectrum. And I'll tell you all the order again. So I'll start from the bottom. And the bottom is, do y'all know, the most dense. So I've got honey, I've got corn syrup, my pure maple syrup, milk, dish soap, my strawberry looking water, I've got my vegetable oil, my green alcohol, and I've got my lamp oil. And they all stay at the top. So why do you think this one's at the bottom, the honey? Because it's the most dense, right? And then we've got something like water in the middle. So we've got water in the middle. It's about in the middle of our spectrum, or dish soap kind of too, because the density, it's not really that heavy, but it's also not as light as our oil, as our alcohol. Our oil is something that's called hydrophobic. It's scared of water. It doesn't like water, so it stays afloat. All right? So that's my spectrum. And again, I'd really love it if y'all took a picture of it and just sent it in to webinar@stemnola.com. We would love to see your results. It's all about that interaction. We really want to see what y'all did. So we are going to put this aside, and we are going to come back to our sugar density column part 2. All right, and this is where we're going to see our final results. So y'all can go ahead right now. You'll get your cups out the fridge or the freezer, wherever y'all put them, or if you just put them on the side, just go ahead and get all that stuff ready and maybe get your area cleaned up and everything. I'll give y'all time to do that. I'm going to put my stuff aside. So we can see that different things have different densities. And another tip I forgot to tell y'all about. So when you have, if you still have yours, if you're pouring it out right now, maybe wait before you pour it out. If you want to set it aside, with this little layer density column, you can add objects into it and see what floats. You can put like a button, or you can put maybe a marble. Like for instance, I've got a washer here. It's like a little metal washer, and then I've got a marble. I could drop this in real quick and see which layer I think it's going to set in. So let me predict real quick. I don't know, I'm thinking it's not that heavy, so maybe it will go in the milk. And I was wrong. It went all the way to the bottom in the honey. And then I've got this marble. I think the marble might shoot down. I don't know. It's not as heavy. Let's see. Maybe, I think it'll go all the way down. I was right about that. I was right about the marble. It went all the way down. So maybe get some household items that you're not too concerned if it gets really sticky or gross, like a button or a marble or a penny, maybe something like that. So you can go ahead and drop those in. Maybe include that in the picture too. Let us know what items you dropped inside. Just something that you don't really, you're not too concerned if it gets dirty with. So, and again, I'll give y'all some time to clean up your stuff. And then I'm going to go back to my sugar density column, get y'all time to clean up and everything. I'm going to get my cups out. I put mine in the freezer so I could get them really, really, really cold, and those molecules can kind of stay together. They're not flipping around too crazy. All right, and let me put them in the right order again. So I've got my red, which is I think is going to be my least dense because I don't have any sugar in that. It's just my water and just my dye. I've got my yellow, kind of orange water that's got 1 tablespoon of sugar in it, and then I've got my 4 tablespoons of sugar with green, and I've got my blue that's got 8 tablespoons, and I've got my cup that has 12 tablespoons of sugar in it, which is my purple. All right, and then I've got, again, if you don't have something like this, we really just want something that's got that cylinder shape, so you can use a plastic water bottle or maybe even one of your cups if you've got a glass cup about that big, and you can just pour your water in that. We just really want to be able to see, our rainbow spectrum. Okay? So y'all ready to get started with this one? Y'all need a little more time, or doing okay? All right. I'm gonna get started with mine. I'll take it slow so y'all can see it. Y'all can pour your stuff, and we can all get the result that we want. So, all right. So, do you notice a mistake I might have made? I started with my least dense. Do you think it's gonna work if I pour my least dense one? No. It's gonna work if I pour my most dense one. So our most dense has more sugar in it, and it's got the color purple, okay? So that's the one we're working with. And we want to do that same thing. This one maybe go a little slower when you're pouring because it's not different substances. It's all water and sugar, so it might mix together. That's what we want to try to avoid. So do it at about a 45-degree angle with your container and pour really, really slow. For the first one, it's okay because it's just the water. It's not mixing with anything quite yet. But I'll just do it just to show y'all. Might have to have a little more patience with this one. That's fine. Practice makes perfect with patience. So let's do that. All right. So we're going to work with our 8 tablespoons of sugar, and let's see what happens. All right. So pour really slow because we want the best result. All right. I can't see it too well because my hand is covering it because I want to be as still as possible. Maybe play the freeze game while you're doing it because you just want to go slow. You don't want it to mix. It looks like it might be mixing together. But we'll try to see and get a more accurate thing when I pour my green. And I still see a little blue at the top, but it looks like it might have mixed a little bit. So, all right. And it looks like my green is mixing in as well. So why do y'all think that might be happening? if it's happening for y'all's or is it not happening for y'all's? Is y'all's looking like it wants to, or are you just getting purple grape juice like me? I would love to know. And why do you think that's happening? Why is it mixing together? That's the reason why we do science experiments, is because sometimes it just doesn't work the way that we want it to. I can see when I pour it, sometimes it's having a hard time mixing just because there's different densities going on. I've got some water that's got a lot of sugar in it, and I've got water that doesn't have that much sugar in it. So I can see it's mostly mixing, but we'll see what happens. I have this water, it's pretty cold, and it doesn't have any sugar in it. Maybe we'll get the result we want, and we might not. It looks like it's kind of floating top, but mostly mixing together. So unfortunately, I didn't get the result that I wanted. I got purple grape juice. It's not grape juice, doesn't have grapes in it, but just definitely please don't drink it. It's got so much sugar in it. I do not want y'all to drink this. But why do y'all think it mixed together? Why did it not work like our layer density column that worked really, really well? It's got distinct layers. Did that happen with y'all, or is y'all's mixing together too? Mine mixed together, I think, because it can have an effect with the temperature. The temperature sometimes, if it's really warm still, and your water was really warm and you only put it in the freezer for maybe like 10 minutes, it may have not got as cold as you want it to be. When it's cold, it's going to keep its molecules at rest, and it's going to be able to give us that layered look that we want. But what should have happened, what I wanted to happen, and did not happen, was kind of the same effect. When I had water that had more sugar in it, but actually,
Dr. Mackey was working on one.
Dr. Mackey worked on one, and he got it successfully done. Thank goodness, because my experiment didn't work. So maybe he did a few more trials than me, but he definitely got it to work. So I don't know if y'all can see it that well, just because it's smaller and this is kind of translucent. It's not super clear, but we've got a way better distinction with this. And maybe some of y'all got the result that I wanted to get, but I did not get. So what we can see with the spectrum, I'll hold it up in light a little bit better. There we go. Hopefully y'all can see that. We've got purple, we've got blue, it's like a teal blue. We've got a little green maybe, but I see green, yellow, I see orange, and I see red. So we've got the same thing going on. That's what I wanted to happen, but maybe it didn't happen because my container was super big and it was just water and sugar. But what's really cool is with different sugar water, I had 12 grams of sugar in this one. We had about 8 grams of sugar in this, and this one worked way, way better. Probably because it's in a more confined space. So if y'all are working with something like a water bottle, maybe yours worked better than mine because my container was so big. But so we got the result that we really wanted to get with this one. And it's really cool because it's not different substances like this. It was water with just sugar, and we just used different amounts of sugar. And you can see they stack on top of each other. And it's the same thing. It's because we've got something that's less dense, and that's going to stay afloat. And we've got something that's more dense, and that's why that was at the bottom, because it's more dense. It's got more of those sugar molecules now, and the water molecules jam-packed together like that. All right. So I gave me a piece of paper. Maybe y'all can see it a little bit better if I do it like that. Y'all see that? All right. I think you can see it a little bit better. Trying to get it in the right light. I wish I could see it on person. Y'all see it and be very impressed if you could see it right here. But maybe you can see it kind of like that. Okay. So, but you get the idea. And for the ones that got it successful, if you got yours successfully done, send a picture of that one as well, because we'd love to see it, because little old me did not get it correct. But that's what science experiments are for. That's why we're here. So it's all good. But with this one, I got the result that I wanted. I like this one a lot. This one's my favorite experiment. But that's okay. So that's what we did, and we covered density, and also you could try to drop different objects in this one as well if yours worked, and see if you get a similar result. Maybe not use objects that are super heavy, but maybe use maybe like a button or a penny and see if it actually stays in different layers. It's up to you. So those are our 2 experiments for today, and I hope y'all got the results that you wanted to get, and I'm so happy that I was able to work with y'all. And we're going to go ahead and go back to those questions real quick so we can see if you got the right answers. So we talked about it during our experiment. If you were listening, which I believe that y'all were, we're going to be able to answer these correctly. So let's start. Why do we think the bottom layer was at the bottom? Why is that? All right. And I'm very happy and very pleased because almost all of y'all got it correct. That is right. The bottom layer is most dense. And you know what? We poured it in first because it was most dense, and that's why. It's the bottom layer because it's the most dense, it's the heaviest thing. And so now we're gonna go to our second question. Why is this top layer at the top? So look in that picture. Why do you think that one was at the top? Remember what we talked about. Remember with density. Why is that one at the top? Think it's more dense? You think it's less? All right, and again, most of y'all got it right. So I'm very pleased. It's because the top layer was less dense, and that's why, because it floated. So our third question, I'm confident y'all can all answer it right. I really think y'all can. Which layer was most dense? And the clock begins. What do you think? And again, most of y'all got it right. So the bottom layer, that was the one that was most dense, and that was our honey. And for our spectrum that worked, that was our purple layer, okay? So now I think we got everything that we wanted to get to on our agenda. We got our vocabulary terms. We talked about buoyancy, and we talked about density, and we talked about Archimedes' principle, and we did some experiments, had some fun, maybe made some mistakes, got a little messy, but it was good. So I'm so glad I was able to work with y'all, and I miss y'all. I wish I could see you in person, but I'm so thankful that we were able to do this thing and do a virtual experience. So y'all have a good day. It was fun working with y'all. Bye.
So those of you all, first and foremost, let's give Holly a hand. Holly is a junior college intern, education major at the University of New Orleans. She's been working with us now over 2 years, and we're so proud and happy for Holly. She just passed out. She was so nervous. We knew she can do it, and she did an amazing job. But what she really demonstrated is what STEM and science and engineering help us to learn, and that is perseverance. It's trial and error, grit. Things don't always work the same way every time. So you have to do it all over and over again. You have to stick to it. And I have a little surprise for you all. This is my little friend. My little friend Alpha is a humanoid. And a humanoid is a robot that try to act like a human. And what we're trying to help kids to understand, parents, and help parents to understand is that we're either training kids from the neck up or the neck down. And if we're training kids from the neck down, this is their competition and they cannot win. These are the type of machines that will be replacing jobs for the foreseeable future. And that's Alpha doing her push-ups, exercising for you all, showing off. And this little robot, this humanoid, has these different motors at every point we have, like a joint, and we can program this humanoid to pretty much replicate any human action, a human motion. So in essence, parents, we have to train our kids from the neck up. We're afraid that COVID-19 is going to exacerbate the disenfranchisement and the replacement of human workers with artificial intelligence, machine language controlled robots like this. And that's why it's very important for our students to learn all that they can learn, because the only way we win in the future is that we outthink the machine. And that's why we do the things that we are doing. Now, you can go to our website, and we have summer camps that's available now. We will be announcing real soon, any day, a virtual robotics camp in partnership with Chevron and UB Tech Robotics that'll be open to everybody across the nation. So look out for that, and you'll learn how to build robots like this. We have a STEM hands-on camp where you can work with instructors like Holly and do these type of experiments at home. We have a STEM NOLA box that we're gonna mail to your home and go through all of these different topics with you. We wanna make sure that you're prepared for the 21st century. But also we do understand that this online distance learning has been challenging. So we wanna create a hybrid model where you all can do this touch and feel at your home. We wanna make sure you have the materials, and we wanna be here to answer your questions and go through it with you. Thank you all for tuning in. Once again, if you enjoyed it, let us know. If you didn't enjoy it, please tell us what it is you didn't enjoy about it. We're working every week to get better. Tell your friends to chime in. We're gonna start giving away some prizes at the end for people otherwise help us do the things that we need, like pictures and send us feedback. But again, we're here for you. And we want you all to be prepared for the 21st century. I'm Dr. Calvin Mackey at STEM NOLA. Thank you all for chiming in. Peace. Remember, social distance.